Welcome to the tools panel. We love tools. Thank you. Thank you. So let's start things off with a quick round of intros. Hello. Okay. Let's start things off with a quick round of intros. So who are you? What do you do? And also, what kinds of security tools do you either build or use on a daily basis?
Hey everyone, I'm Nat. I'm a security engineer at TrailerBits. And on a day-to-day basis, we're generally using tools like static analysis and fuzzing on a day-to-day.
Thank you. So I'm Patrick, the CEO of Fuzzing Labs, and as the name suggests, we are doing a lot of fuzzing. So we are basically building security tools and dedicated fuzzer for either client side or smart contracts.
Thank you. Hey everyone, I'm Gary. I'm a software engineer at Electric Capital, and I work on security tools that kind of focus on like post-deployment. So work on like a code search tool. And surfacing information that comes out after contracts are live and deployed.
Hi, I am Ori. I work at Certora as a developer and in developer relations. We're developing several security tools. One of them is the Certora Prover, which is a formal verification tool for smart contracts. And the other is Gambit, which is an open source Solidity mutation testing tool.
Hi, I'm Bhargav. I'm part of the research and specifications team at the Web3 Foundation. I like to call myself a full-stack verification engineer. So I'm interested in the whole spectrum, right from like analyzing consensus protocols all the way to verification at the code level. And mostly right now I'm focusing on verification tools for the Polkadot ecosystem.
Hi, I'm Yannis. I'm co-founder of Dedaub. We have a public blockchain explorer that's geared towards security. So we have probably the best decompiler for EVM bytecode out there. So we offer free tooling for all sorts of security investigations. But our proprietary tooling has to do with static analysis as well as dynamic analysis of transactions. So we do both bots for monitoring, and we have a language for specifying those. And we write a lot of static analysis for code.
Awesome. And I'm Fraser, your moderator. OK, so can someone or a few of you give your sort of pithy couple-sentence analysis of the state of tooling in Web3 generally?
It's good. So, I mean, we can concentrate on the negatives, but if I were to give a two-sentence description, considering that this is a young domain, we have very, very good tooling, security tooling, compared to much more mature software engineering domains. We have probably the most advanced versions of tooling from the formal verification side, the Certora Prover, et cetera. From the static analysis side, I mean, I've been in the static analysis community for over 15 years, but the best tools we have ever put out are in this domain. And it's all because there's so much money at stake. So we can complain. There are definitely problems, but it's good to see where we are in the whole universe. And we have some pretty awesome tooling.
That's actually kind of answers my second question, so I'm just going to throw that out there too, and you can answer both. So how would you say the tooling landscape is different in Web3 compared with Web2?
Yeah, so there is one clear difference between Web3 and Web2, right? That you can't use security through obscurity in Web3 because like most of the code is open source. Like attackers can spend months analyzing it before they launch the attack. So one of the key differences I would say is that since everything is open source, the analysis has to be much stronger, and obscurity cannot be used for security.
I think one of the main differences between Web 2 and Web 3 tooling from the point of view of the user is that the user base of tools in Web 3 is much smaller. So if you need to look online for answers for your questions or look for video tutorials about how to do something with a certain tool, you're probably not going to be able to find it, or at least not nearly the same ease or quality.
Yeah, I think to expand on Bargov's point, one of the main differences I see is like because it's open source, all the code is out there. There's millions of dollars of value behind it. You get this really quick flywheel where there's auditors and security researchers, and they can go audit the code, use all these tools, give a bunch of feedback, and so you get this really nice virtuous cycle. And so I think it kind of leads to the tooling being really good and also evolving at a really quick rate.
I would echo kind of the previous answers on the panel. The only thing I would add is that I think Web 2 tools in some ways are also more advanced than Web 3 in terms of the usage in different code bases and usage across applications. And so I think there's also, in addition to that, there's also kind of the adoption and kind of more having developers actually integrate with like existing static analysis tools and fuzzing is definitely something that like should be applied to all code bases, and I think is definitely like something that is much more apparent and needed in the blockchain space.
So I disagree a bit, actually, compared to what you were saying. If we are speaking about Web3 in general, I think there is a huge gap between the different blockchains. I think if we are speaking about Ethereum, the maturity of the toolings are really good, and we have a bit of everything and so on. But if you compare to other chains in general, there is definitely a lack of static analyzer, further no formal verification on some chain, especially if you also take a look at all the new L2, ZK stuff. There is a lot of new either smart contract language, circuit, ZK circuit, and so on. And in this area, basically everything needs to be built. So if we are only taking a look at Ethereum and EVM, yeah, we are pretty mature. If we take a look at the rest, it's nothing compared to what we have.
Yeah, I mean, definitely would agree with that. One big difference that I'd like to point out is that this is a perfect playground for security tooling. It's the only opportunity one ever gets to have all the code open, all the test cases, pretty much, all the past executions permanently recorded. You can do pretty amazing security tooling in this space, in the Web3 space. And the other thing that helps tremendously is that it's small size of code bases. Like a little over 5 years ago, I was doing similar things. I was doing static analysis at Facebook. The Facebook Android app, which is like the little app that you install on your phone, that's 100,000 Java classes. That's the deployed bytecode, Java bytecode that goes in your phone. Like 100,000 Java classes. Imagine what tooling can analyze that versus the tooling that can analyze, 50 smart contracts that are typically what constitutes the average DeFi protocol that manages so much money. So we have a perfect playground, and we have gotten a lot of advanced tooling, which is great. But certainly, it's true, it's only limited to EVM, and especially even in EVM, mostly Ethereum.
Great. So that's somewhat related to this next question, which is about how you hope to see the state of tooling change moving forward. I guess we got some of that at the end. Yeah.
We would like to see some more one-stop shops. Currently, you get different tools to do different functions. So you get deployment, or you get compiling, or you get analysis and fuzzing. So some tools have already started to move in this direction to great success. I think we're going to see more of that. And obviously that relates also to the issue of multi-chain, which is in general a bit of a lacking area of vulnerabilities for many of the tools.
Yeah. To give you an example, in our cases, we are building security tool open source, financed by grants from foundation. And typically, in my opinion, that's the way it should be. I definitely enjoy the different tools that most of the guys are building, and I'm playing with them with all of them. But the fact is, for me, when you have a blockchain and it's creating its own smart contract language, its own consensus and so on, that should be the one that is financing and developing security tool to basically give that to the developer. It should be at least them that is doing the first step, and then different security companies and teams that basically build on top of that and provide audits and everything. But for me, it shouldn't be the other ways.
I think there are a lot of existing tools, like for example, for static analysis with Slither, for example, that do provide like a lot of results that developers and like security researchers have the opportunity to triage. I do think there's probably room for improvement in terms of reducing false positives, just to make sure that it gives you like developers and users just a better idea of what is more likely to be wrong, and kind of an ease of experience in terms of understanding like what code might be affected. And on the flip side, I think false negatives from the fuzzing side as well, to make sure that fuzzing tools can be extended easily and nicely, just to make sure that bugs that should have been caught through fuzzing are actually caught. And so I think there's a lot of room for improvement in kind of the existing tool space currently.
Yeah, maybe I can give some insights from like the Polkadot ecosystem. So the whole ecosystem tech stack is based in Rust. And it would be great to see some tooling for Rust, which even before like security or verification, the first thing is like program comprehension. So it would be great to see tooling which improves like program comprehension, because it's only when the developer really understands what he's doing that he can come up with invariants and so on. So that's like the first layer that I would love to see being developed. And of course, like after that comes static analyzers, and surprisingly, there isn't that much options which are robust enough to be used on like production grade code. I think my feeling has been that at least for like Rust tools, most of these tools are like academic in nature, and in academia you tend to prioritize novelty over robustness. And so that I feel there's a huge potential here where there are great ideas, but these ideas have to translate to like robust tools that can be applied on production code.
Yeah, so I would definitely agree, but there's a standard added here, which is there's no money in tooling. So, and especially in comprehension tooling, like there are well-known studies, like even Google has put something out that says nobody cares about offering tools to help the programmer understand. That's considered low value. So you need to go directly to something that has value, which is like security analysis. So I agree that there's a lot of need there, but it's not going to be filled by the market so well. Foundations may need to step in to give better tools at that level, because the market will not step in there. And imagine this market with, at best, a few tens of thousands of developers, at best. compared to the overall, the Web 2 market with millions and millions of developers. I mean, there we start now to see some security tooling that's, and comprehension tooling that has general applicability, but it's an order of magnitude larger market. But certainly I will agree with everyone that there is a lot of room for improvement. There are things we can focus on, both on the false positive, false negative side, but there's also a big potential for disruptive innovation here. And where do I want to see disruptive innovation? Well, first of all, we just saw LLMs, we saw AI come in, and we've seen completely trivial uses. Like you find like a text generator that hallucinates, and you feed it your program and see what we'll say about it. That's not very interesting. What I'd like to do is move the frontier of what is considered automation. Have a neural net come up with specifications for the Certora prover, for instance. Have something like that. Have deep automation, something that will really push what can be automated versus what's now delegated to humans, and that can get us to the next level with much, much greater automation, some good security insights encoded in our tools, but at the same time, the automation will come from LLMs or something similar. So there's definitely a wide open horizon for things that are going to happen in the next 2, 3, 5 years. Lots of potential for innovation.
Thank you. Taking this from a little more of a visionary perspective back down to really, really minute. We touched a lot on false positives just now. I'm curious if anyone else has any opinions, feelings, thoughts about false positives.
They don't matter.
Ooh, interesting.
Nah, I'm being a little provocative. But they obviously matter, but they start to matter a lot at above the 90% rate. That's the surprising thing. You know, give me a true vulnerability 1 out of 10 times, I'm still happy. If it's a true vulnerability, that's tremendously high value in this domain. So I don't care if you give me a few false positives. It's not like I'm trying to get the attention of a bored programmer programming iOS applications, and now I need to give them like extremely low false positive rates. I mean, that's not the game here. The game here is give me high-value vulnerabilities, even if 9 out of 10 times they turn out to be false. Now, if it's 99 over 100, yeah, that's way too much. But we can suffer a lot higher in terms of the false positive rate. So that's why I don't consider this to be a huge problem. That's my controversial opinion. I had warned beforehand.
And do you think that tools in this space all seem to share that opinion, or do you think different tools in different segments of the space have different reactions to false positives? And this is kind of for everyone, including you.
I have to qualify, first of all, sorry, and that's the last thing I'll say. It depends on the severity of the vulnerability. If the tool is ambitious enough to go for severe vulnerabilities and end-to-end, that's when the false positive rate does not matter. So I think most people will agree to that. But
so false positives can actually help in program comprehension. Our tool, for example, is iterative in nature. So you will eventually be able to eliminate most of the false positives, but in that process, you are focusing on the parts of your program that are the riskiest, at least in the eyes of the tool, and that in itself can help make your audits more focused, your testing more focused, and reduce errors in an indirect way.
I do think in terms of something like results from like a static analysis tool going into like if you're just kind of running it on code and seeing results, it's possible that like a lot of those are false positives and maybe one of them is a true positive. But still, even then, triaging those results and going through them and actually really understanding in depth what the system is supposed to do and how is it supposed to work is a practice that kind of needs to be done because that tool can essentially help you determine those vulnerabilities and those risks beforehand. I think there was a recent study that was just released that was, if you run, based on previous code bases where Slither was run, it could have saved like 150 million in funds. I think that goes to show that developers really need to take results from static analysis tools carefully and really understand what are the true impacts of, even if it doesn't affect your code base right now, how will it affect your code base in the future once you do a code upgrade, once you do a migration? And actually understanding like end-to-end what that impact has on your system, because there's a lot of things that can fall through the gaps. And so it takes a lot of time and effort to really go through those and triage them.
I think on like the ergonomics and DevX side of things, false positives can be bad. Just because if you keep running tools and they give you these false positives that are low severity, you kind of get desensitized to it and almost like annoyed sometimes. Like if you ever run npm install, you'll see it tells you there's like 5 warnings and things you should fix, but like how many of you guys have actually looked into that? And so, that's possible that for some of these tools that can also happen, where you might just be like, I don't want to run this anymore. It's like too much noise. So I think that's definitely one concern that we should have when it comes to false positives.
So one of the other ways of like getting rid of false positives is to use maybe some kind of symbolic execution, so that after the tool gives you this possible issue here, you would want to have a concrete input or like a concrete test, which exposes that vulnerability. So maybe there are ways where you can combine static analysis with some symbolic execution to improve the false positive rate.
So I totally agree on that. The fact is, most arrive at a certain point, most advanced security analysis tool will actually directly include symbolic execution engine inside, because if you want to be able to find some complex vulnerability, you will be able to maybe suppose or at least get a range of a possible value at a certain point in time. So what I think is definitely valuable is symbolic execution to actually get a closer look of what is really happening. And I think something really important to have, and it's typically the first time I saw that was in Slither, is the confidence of the vulnerability. And I think it's basically what potentially matters the most. If you have a critical and the confidence on that is really high, it's not the same than a critical with a low confidence. So maybe a first step for the developer to do is actually to take a look at all the vulnerability with a high confidence score, and then go to the rest.
Yeah, I definitely agree that static analysis should be used in combination with other tools. I would also say, like, if you do actually find a true positive with Slither or any other tooling, that should be a sign that you should be fixing that vulnerability, that you should be fixing that patch and probably writing like a unit test or some kind of fuzzing test even, just to make sure that that's no longer exploitable, so that in the future when you're updating your code, you've checked to make sure that it doesn't repeat itself. And just making sure that you're always running those tools like as you change your code, and not necessarily just like write all your code first and then do the Slither and like run static analysis or formal verification or fuzzing. Just because once you get to that very end, most likely those static analysis results are going to be never ending. Fuzzing is going to be very difficult to get up because it's such a large code base that you may not have considered like what are your invariants beforehand. And so ideally, if you are running these tools like as you're creating your code, by the end you shouldn't really have like a long list per se of like findings that you should be like keeping in mind within your code base. It should be relatively succinct because it's something that you've thought about as you're building your code.
And do you find that's how developers tend to use these tools, or what workflows are you actually seeing in real life?
We'd definitely like them to make sure that they're doing this throughout this security work process. I think it very much depends on the project, and especially if a project is set up with thinking about their invariants beforehand, thinking about like what their code is supposed to do, it's noticeably much easier to get fuzzing set up, and it's much easier to triage results because there are not that many results. So there's a very noticeable difference between those projects, and from that, it becomes, from the project's perspective, much easier for them to analyze potential vulnerabilities or like risk with like external protocols. And so from their side, they have kind of a more, they have a safer posture, which can help them essentially future-proof their code, but also just make sure that their current versions are safe.
Yeah, a lot of developers have that misconception that you should use tools as the last thing in the development lifecycle, right before or even right after audits. And actually, the biggest value you can get from tools is from using them from very early in the process. It just gives you more economic value because the mistakes that you have, especially in your design, are going to be a lot more expensive if you find them late in the process rather than early. If you're going to do it anyway, please do it earlier.
I would also add that, especially for going, like after you've written your code, going into like audits or bug bounties or any kind of other eyes on your code, any third-party opinions, having run Slither and having the fuzzing set up means that other people looking at your code can then focus on very complex bugs that integrate with protocols or different contracts. And so the quality of those bugs are likely much higher than those of like results from static analysis, because these tools will help you find kind of the low-hanging fruit and maybe complex interactions, but it means if you've already run those tools, when you get to kind of having that third party look at your code, that it's much easier to actually understand what's going on, but also identify potential bugs.
Okay, I'll go back and push back a little on the idea that a static analysis tool especially can give you good estimates of its own confidence. I mean, confidence is a great thing, but we need to be really careful when inspecting results at a certain level of confidence, and I'll explain what we are noticing and kind of why this is happening. There's this old anecdote in business settings. You have a professor, and the professor is teaching her students everything about stock picking, and here are all the criteria for seeing whether a company is doing well, and you have your PE ratio, and you have what the executive team has sold recently, and you have whatever criteria you want. So the entire class is learning about all of those. And the professor is like, okay, so give me an algorithm for finding the best stocks. The students come up with something, and they state their criteria, and they run the algorithm, and it's like, there are no stocks like that. And of course, there are going to be no stocks like that. In everything that has money behind it, if you only focus at what you can be certain about, if you only focus at the highest confidence, you're not going to find anything. And it's the same with analysis warnings. If you only look at high confidence, basically that's clueless code most of the time. So it's not going to hold any money. If you do high confidence and holds a lot of money, that's an extremely rare occurrence to find anything. So oftentimes, one needs to inspect a lot more than the high confidence warnings. Why? Because the analysis itself, the automated analysis, it knows of one threat, and it knows of a guarding pattern against that threat, and it thinks it sees that guarding pattern, but it's not really there. And you have a real vulnerability. And a human needs to come in and find that even though I see a low confidence warning, this is really something that looks a little suspicious. So yes, definitely we want analysis to tell us how confident they are. Yes, we want to focus on the high confidence, but only if we have limited time for inspection. If this is really a project that we care about, you need to inspect nearly everything that the analysis tells you about, because this is a lot of money, and the analysis is just doing its best, and it's just a machine.
I want to refer to a few things that Yannis has said before about confidence in terms of formal verification. So you said before that maybe in the future AI will produce specifications. So there is a running joke that formal verification makes sure that your code and your specification have the same bugs. And that's a true risk that you can have with generated specs. It might not be what you mean them to be. And that ties into the confidence problem that we faced. And we tried to solve it using a different way with mutation testing. The basic idea is that you take your code, Solidity code, and include a random fault in it. And we call that a mutant. And the idea is that it resembles a code with a bug in it. So it should fail somewhere along your testing suite. Maybe static analysis will find this mistake, or fuzzing, or your unit test even. And that gives you some estimate of confidence, seeing how many mutants were caught, we say were killed, and how many were not. And it's pluggable with all kinds of different tools.
Is there a chance that maybe generated specs at least will be more different than specs written by the people who wrote the code? Like it seems like it could be an interesting moment of diff, although maybe the generated specs are like so kind of average in what they generate that they also incorporate sort of the most likely kind of bug. But I don't know. Any more thoughts on like generating specs?
So yeah, I guess that will depend on the exact AI technology that will be used to produce these specs. I think that there are two main problems. One, they're going to see only specs that humans wrote, and well, most of the specs are not catching bugs, right? And the other is that we see that the more tailored the spec is to your program logic, the more kind of unique bugs you can find. If it's a generic bug, there are other technologies that are very good at catching bugs, like static analysis, and you're going to miss out on some of the edge of that technology if you cannot really find something that's very different from the other programs that have been used to train the AI.
Okay, great. Thanks for coming with me on the small AI tangent. Okay, so I'm curious if there have been any developer responses to results from either your tools or tools you've seen that have been really surprising to you or taught you something about your tool or the state of tooling more generally.
Yeah, there is always some funny responses from developers, to be honest. Like you find a bug, they fix it, and they say it's not the bug. But why did you fix it if it's not a bug? But whatever. So this kind of stuff happened all the time. What happened as well is that the tool is too specific or not specific enough. And again, that's the main issue with, again, if you want to have a high confidence on, I don't know, reentrancy, we're going to really be specific on which type of reentrancy, have a high confidence because based on the CFG, the EVM bytecode and so on, we can affirm that there is a reentrancy bug. But if it's like another variant of reentrancy, if you have been there for like 5 or 6 years, there was only one kind of reentrancy back then, and not multiple of them. So definitely the tool at the time was only able to find the, let's say, the DAO reentrancy, but was not able to find the new read-only reentrancy or whatever that we have right now. So there is definitely updates to do on the tools, and the fact are the developer, some of them think the tool is magic, and that he will do all the job for you. And that's my controversial opinion about formal verification, because everyone wants to have formal verification, but for sure, if I'm formally verified that 1 equals 1, it doesn't mean I'm formally verified. So for me, there is also a notion of, let's say, a timeline applied to tools. Static analysis tool should be kind of one of the beginner, finding all the long inputs. Then you are doing fuzzing, and then you are maybe doing symbolic execution, and then you are doing formal verification. But it shouldn't be the other way around. It shouldn't be like a mixed up in different order. It's really a process, and basically that's what is, I think, missing in most developer mind.
I think one common question that we get around when we do like fuzzing workshops and sharing essentially how to fuzz is that if the fuzzer passes, then it means there are no bugs, which it only means that there are no bugs within that iteration and those attempts in those tries that it attempted. I think the other thing is that the invariants in general, any tooling that you use to test your invariants, they're only as good as your invariants are. And if your invariants are wrong, then your tooling isn't necessarily actually going to tell you much about your code, which is why it's so important to actually start with like what your code is supposed to do and figure out what those invariants are. I mean, ideally before you even start building it, but that gives you a better idea of what you're aiming for and what your code is supposed to do. And only then can tools actually be useful and helpful in determining whether those actually hold.
Sometimes users on CodeSaw will use it to search for dependencies, which wasn't really something we anticipated, but it lets people dig into the supply chain of the dependencies, which we don't, at least in Ethereum, there's no widely adopted package manager, and so kind of highlights the need for some of this basic infrastructure for developers that it's very common in Web 2 programming languages. So we're kind of missing a lot of that key infrastructure because I think a lot of the focus is on the logic and the contracts themselves when it comes to tooling, at least, which is of course very important as well. But yeah, it shows us there's still some more work to be done on the infrastructure side.
So one of the reactions usually when I try to show a formal verification tool is that, okay, this is great, so I need to write a lot fewer tests. But that's kind of not the best way to go forward, because in some sense, tests are specifications, right? Because if you have a code with a lot of corner cases, well-crafted tests really tell you what the spec is. So yeah, so even with all these verification tools and static analyzers, tests are still the first thing that you would need to write. So it's these tools are not panacea, so they don't get rid of the need for writing good tests.
I don't have exactly good stories of user feedback, but mostly comments on things that were said earlier and also controversial statements. So first of all, I'd like to point out that the tools are a continuum, right? I mean, there is perhaps formal verification against specs on one end, but everything else is very much a continuum. It's not just static analysis. Static analysis and symbolic execution and fuzzing could all be part of the same tool. Like in our case, they typically are. Deep symbolic understanding of the program could very much go inside the static analysis tool. It could be trying to derive specifications. We're trying to do that. One thing that I think might be a controversial opinion is that the protocols that I want to use formal verification on are some of the worst written, because I cannot understand the code fully in full confidence as a human, and there I definitely want some formal verification tool where I can just write in terms that I understand the specification and have the tool tell me, yeah, it's true. After a deposit of 0, the shares remain the same. Oh, great, because I couldn't tell that myself as a human. That indicates really badly written code. So that's kind of a controversial or negative opinion. But we have to see that what we're doing in this space is we're pushing the limits of tooling and their contribution to programming. We are having very, very advanced tools, and this is very good to see. We are seeing formal verification fully used in practice for protocols that manage lots of funds. Now, what are the limits there? We're discovering them in this community. We don't exactly know. It's not like other communities have done this, other software development domains have done this. We are at the forefront there. We will see what can be the impact of all sorts of tooling on automating security of software.
Since we've had a few controversial opinions already, I'm just going to open the floor for more of them. So bring your best and most controversial opinions now.
I have a controversial opinion for developers, probably not to my peers. But if you've tried a tool and didn't like it or couldn't manage to use it well, and it was actively developed for over a year, you should give it another chance. Most tools have had some amazing development in the last year or so, and they could bear very little resemblance to the experience you've had before. It's very easy to write things off. Oh, I've tried it like a year and a half ago. It was too complex, couldn't run on my code. You should try to do that again. You're missing out.
Yeah, completely. And they actually should put that in the CI/CD, because the fact that the tool will evolve a lot will also potentially find bugs in the future. I'm thinking typically of the study you mentioned, Nat, about the fact that Slither actually find bugs, like on some contract, and if developer was using Slither, they will have find the bugs. Sorry. The question I will ask is, do the bugs that was detected in this study was actually bugs that was already on the tool at the time the contract was available? Or is it like new detectors on Slither that actually find the bugs?
I'm not sure they did close analysis of the diffs between those contracts. So it's against the, if I'm not mistaken, the current version of Slither.
Any more controversy?
We should have competitive teams.
I can, yeah. I mean, we are all against formal verification, so that's
No,
too bad.
I'm not. What? No.
No, so my controversial opinion is, yeah, formal verification is, there is way too much noise about that for not that much plus-value, in my opinion. So it's a really, really controversial opinion. But for me, yeah, I mean, it's something that is proven to be efficient and so on. I also disagree of what you were saying previously regarding like we are completely new in this area, like we are like on top of the game and so on. I mean, I think most of you in the room have taken a plane to come here, and I think typically the aerospace plane security is kind of a top of what exists in terms of assurance. Make sure that if your plane get any problem, you will get multiple backup and so on. We are not even close to that, in my opinion, on smart contract. So there is definitely some room to improvement, and I definitely think we have still a lot of tools and stuff to do. And yeah, we are not on top of the game on that, clearly not in my opinion.
I do agree that there's a lot of tools that exist for developers to use to make sure that their code is safe, but then that puts the onus on developers to actually integrate them, use them properly, and use them in the way that they're intended. And I think that's one area that it's a very it can be difficult to do because people just want to keep writing code and keep building new features or keep building new things. But just taking some time aside into thinking about security and thinking about how to write safe code while you're developing code goes a long way.
Yeah, so if I can defend a little the earlier statement, and then we can get back. Clearly, there are domains that have had formal verification in the past. I mean, in processors, in hardware, subroutines have been verified routinely since the Intel bugs, like the AMD square root routine has been verified. Control systems in trains, in airplanes have been verified. General purpose software development, completely open, that can do any calculations whatsoever. It's not a closed control system, has not been verified as aggressively as software in this domain. So we are, to a great extent, we are at the forefront. And I do believe in formal verification, but I do think that the extent of its applicability and its overall impact in the industry is still to be determined. We don't know whether, how much it will capture of the security assurance of the overall space. I mean, I think everyone will agree to that. But it's this community is making great strides towards popularizing formal verification with various companies here well represented. But yeah, I think the truth is somewhere in the middle there. But when I said before we should have competing teams, I meant perhaps the people who will be convinced of the value of the tool should not be the people who are developing the code in the first place. Just like we have coders and auditors, to some extent, it should be, for some kinds of tools, not for all of them, it should be coders and quality assurance engineers, something. And I know that's kind of an old idea, it's tired, we kind of don't like the sound of it, but you do need some sort of competitiveness there. You don't want to always be trying to convince the person who developed the code alone. You want to convince an adversary, so to speak. That's what I meant earlier.
Yeah, so another reaction to the formal verification hype, and maybe tying into the question about surprising customer reactions. We found out that for different people, it could be a lot easier or a lot harder to come up with invariants or specifications. And it seems to be somewhat of an independent skill towards a good code writing. So people can be really good at writing complex or efficient smart contracts and struggle with writing specifications and vice versa. And yeah, I don't know if there is a good predictor for that trait.
Okay, I just wanted to leave like 2 more seconds in case any last-minute controversial thoughts came to the surface, but it seems like not so much. Okay, so we've talked a lot about smart contract security that's just been ambiently around, but there are also many other layers to like the DeFi stack, right? We have the protocols, we have maybe some bridges, we have wallets, we have all sorts of stuff. So what parts of the stack do you think could be better served by existing tools? And how would you like to see that, change moving forward?
I think the rest of the stack is definitely under threat, but it is very much a Web 2 security issue, not so much a Web 3 security or DeFi security issue. So in a sense, we all recognize that there is a need there, but I don't consider myself at the forefront of how this can be addressed, what can be the next huge step in the Web 2 security space. In anything that's outside the smart contract space, anything that's outside the core crypto space, let's say.
So I can mainly speak about basically fuzzing clients and auditing clients, which is what we are doing basically on a day-to-day basis. So typically there is clearly a lack of tool on that, both at the language level, like Rust, Go, and so on. There is some toolings, but nothing like no extra stuff for blockchain. There is definitely a lack of tools for blockchain framework. I'm thinking of Substrate, Cosmos, and so on. So there is a lot of documentation and so on. But in my opinion, there is definitely a lack of tool of, okay, I'm building a Substrate blockchain. Can you find out if I'm not like providing any API publicly that shouldn't? Can you verify a bunch of stuff and so on? So clearly something is missing in the ecosystem. And even in terms of fuzzing, I've been doing fuzzing on layer 1 and chain for quite some time, and differential fuzzing as well. And typically this kind of stuff is something that is only financed by the foundation, and the foundation need to do the work and put money on the table, because of course a differential fuzzer like the one I built with Sigma Prime, Beacon Fuzz, is only applicable either if you are doing bug bounty and want to find bugs, or either if you are the foundation and you want to find bugs on your chain. Otherwise, it doesn't make sense to build the tool as a product, because it will be only usable for one specific scope. So typically in such cases, those tools need to be built by some people, financed by foundation, in the same way that foundation finance, for example, multiple clients to get diversity of clients. So in the same way, they need to finance these tools, but it's not possible to make it a product on itself. So it's more like pure research and development and securing the chain itself. And it should be the same for all of them.
I think there are generally many areas of growth that like automated tooling can extend into. Like for example, for bridges, yeah, you can definitely test like the smart contract on both sides using like the existing tools. But I think there's also a lot more room for additional automated tooling and like the locking of funds on one chain, the minting on the other, or vice versa. And so that kind of ties a little bit into differential fuzzing in terms of like if there's a reintegration of like different functions on both chains, but generally just more kind of end-to-end tests and kind of being able to test more there. There's a lot more potential that it's going to be very protocol specific and very dependent on what you're trying to build, what invariants you want to actually hold, and what you're trying to test. There's not necessarily a one-size-fit-all, just because of how unique and how different all of the existing contracts and protocols are outside of just the realm of smart contracts.
Yeah, I think one area that could use some more attention is it's kind of like fuzzy area of like behavioral security. So this kind of extends to like wallets, having standardized UXs, so you're not just like signing a bunch of gibberish like zeros and ones and letters, even to like standardizing, audits and package managers, so that users and devs and security researchers have confidence about what they're looking at, and they can actually point to like what things are being imported and what versions of code are being used. And so all of these kind of contribute downstream to security. And so, like Web 2, they have like this like audit standard called like SOC 2. And so, maybe at some point like DeFi or crypto has its own version of SOC 2, where it's like, oh, this thing is like had Slither run against it, or Tor or whatever, and so on, and it gives a lot of users more confidence and actually helps us like push the industry to better adoption, because each user that has a very poor like experience getting rugged or just making some mistake, like they're probably not going to come back. So we kind of need to like dedicate some more attention to the UX of crypto and the security implications there.
I would like to extend Gary's answer there. So I think it's very important to also look at security from the user's point of view as well. So I think Web3 in general has brought in a lot more ideas and notions about like access control, with notions of proxy accounts, account abstractions, and so on. And it would be interesting to have tools which exhaustively check if there are any ways of accessing your account without having the credentials. So these kind of basically tooling which helps you to to verify that the access control system works as intended.
Great. So it looks like we have about 5 minutes left, so I'm going to ask one more question. If I'm a DeFi developer, I'm starting a new project. First of all, how should I evaluate? There's so many tools. How should I evaluate what to use? And how can I think about setting up sort of a long-term tooling pipeline?
I would say start with specifications, start with identifying what your code is really supposed to do before you even start writing code. That way you have an idea of where your target is, where you're aiming towards, and like what you're even trying to build. And then really just integrate security tools like Slither and Echidna into your CI pipeline, just to make sure that every time you're updating code, you've decided, my code is going to support a new feature, run Slither on it, write a small fuzz test on it. Making sure that you're essentially updating and making sure that the static analysis results are triaged and the fuzzing is up to date according to what you're trying to build, and kind of keeping your specs up to date. I think that's the perfect way to start, because if you start with that, then you're essentially growing a list of your specs, and like your unit tests and your fuzzing tests can essentially help with identifying what your invariants are, and it becomes much easier to actually create like a mental model of your code base and identify like what and where things could potentially go wrong, either in the future when you update and like add a new feature, or just like make changes to your code. It gives you a much better idea of how you have set up your code, and where like potential problems are likely to be.
I would say, first of all, there's lots of tools to get started with a new project right now, or for developers that are just getting into the space, or they're launching a new project. So obviously they'll start from the free ones. They will run Slither. But first of all, you need to write lots of test cases. And then you need to write parametric unit test cases, like good things that do invariant-based fuzzing. And we have Foundry has an amazing facility for that, best that you can get in almost any software development domain. So you start from those. You start by writing your invariants and having a fuzzer that knows about invariants generate tests. You go and you run a static analysis tool. And then you are there and you've done the basics. And you're thinking, do I need to write specifications? Do I want to write specifications? Am I skilled to do that? We've already eliminated 98% of the developers right there, because at least in most projects, there's not even sufficient test coverage, let alone all the advanced things that we're talking about. But if we're going to something more sophisticated, yes, you then think of all the a little more advanced, maybe proprietary tools, maybe writing specifications, maybe using the Certora prover in a pay-as-you-go way, or commissioning if it is going to be a project that has the budget for that. But that's kind of the gradation. But at the beginning level, there's amazing tooling already. I mean, like I was saying before, I've been very pleasantly surprised, even by I don't remember the exact terminology in the docs, but the parametric unit testing in Foundry. Just write invariants and I'll generate good tests for you within those.
Yeah, so I would say like the first thing is to start with a clear threat model, and then also clarify the basic trust assumptions that you have when you're building the system or the protocol. And there's actually in the tooling landscape, there's an inherent trade-off between automation and expressivity of the kind of bugs that the tool can detect. And you can't have usually both of them, right? So you either go for the particular use case that you have, you either go towards like automation where you get security guarantees, but only for a particular class of bugs, or if you want to verify like the consensus mechanism of the protocol itself, then you would have to invest a lot more time and effort, and it's always worthwhile to think if it justifies the time and effort that you invest in it.
Yeah, I agree with my peers. You should definitely start early if possible. Try to use the more generic, less specific tools first. And one important thing that I want to add is that you need to evaluate your testing as you go. If you find lots of bug in a specific area of your code, obviously you'll want to focus more there. And maybe controversially, if you don't find any bugs, that's even worse for you, because then you don't know, you have more unknowns for you. Like, I would be even more paranoid if I can't find many bugs in my code. But definitely do some reevaluations as your code matures, and remember to do this once in a while instead of saying, hey, I have no new bugs, that's it, I'm good to go. Not at all.
And I think also something to for the beginner developer, it's also reuse existing library. I mean, we don't have anyone from OpenZeppelin, but I think they are a good example of basically some kind of best practices that you should do. There is multiple templates of contracts, so there is a huge chance that you can basically start from that and using what is already provided to you as a basis, and then just ramp up on top of that. So I think it's also really important to actually take a look at what exists and is already secure by default.
I would also just add, in addition to not reinventing the wheel, just start small in terms of like what you're actually trying to build, and don't just create one piece of code base that has like 15 different features and then treat that as your proof of concept, just because it's going to be really hard to understand how is that code supposed to work, and what are the potential impacts of a code base of that size. So if you start small instead and start with like a minimal viable product of what your code base is intended to do in the future, and then by some version you'll have essentially what your code is end to end, and you do that piecemeal, it's much easier to actually understand what the impacts of adding new features and new code is.
Great. Okay, I think that's all we have time for. So thanks to all the panelists. Thank you all for coming and listening. We really appreciate it.